This video talks about Taylor's formula with remainder. Taylor's theorem tells about if a function f can be differentiated n plus 1 times in an interval I containing c, then for x in interval there exists key between x and c. So this is the Taylor's formula with remainder. R sub n of x is the remainder or error between the actual function value, which is f of x, and the Taylor's polynomial approximation, which is f of c plus f prime of c multiplied by x minus c plus dot 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 plus f raised to the power of n at c divided by n factorial multiplied by x minus c raised to n, where we can determine the error by using this formula here, which is equal to n plus 1 derivative of f evaluated at key divided by n plus 1 factorial times x minus c raised to the power of n plus 1. Sometimes this formula here is hard to find. So what we're gonna do is to take the absolute value of both sides. So this is called the Lagrange error bound. So we take the value of the error, which is less than or equal to the absolute value of x minus c raised to the power of n plus 1 divided by n plus 1 factorial times the maximum absolute value of n plus 1 derivative of f evaluated at key, where the maximum value of n plus 1 derivative of f evaluated at key represents the maximum value of derivative function evaluated at key, where key exists between x and c. Instead of using the n plus 1 derivative of f evaluated at key, we have to think about the maximum value of that function would be, since we're not able to determine the exact value of the given function. Example, if we approximate sine x by x minus x cubed divided by 3 factorial for the absolute value of x, which is less than to 0.5, what is bound of the error? So this is the formula that we're gonna use. First, we're gonna find the value of n, x, and c. Our n value is the last degree that we see here, which is 3. And we know that x is now bigger than 0.5. And since it's a Maclaurin series, it's centered to 0. Next, we replace the value of n, which is 3, and x to 0.5 equals to n plus 3 plus 1 equals to 4, evaluated at key divided by 4 factorial multiplied by 0.5 raised to the power of 4. It said here that we should take the fourth derivative of our function, which is sine x. So the fourth derivative of sine x, the first derivative of sine x is cosine x. The second derivative of sine x is negative sine x. And the third derivative is negative cosine x. And the fourth derivative is sine x. Sine x evaluated at key is equals to sine key divided by 4 factorials equals to 24, because 4 times 3 times 2 times 1 equals to 24 multiplied to 0.5 raised to the power of 4. In here, we don't know what sine key is, but we know that the sine function has the maximum and minimum of 1 and negative 1. So we take the maximum value of sine, which is 1, and multiply it to 0.5. So instead of using this formula here, we're gonna take the absolute value of the error. It would always be less than or equal to 0.5 raised to the power of 4, which is equals to 0.0625 over 24. So calculate it, and it is equals to 2.6 times 10 raised to the power of 3, or in decimal notation, it is equal to 0.026. So the error of this is 0.026. Next example, determine the maximum error of the approximation. So this is our given and the formula that we're gonna use. So first, we're gonna find the value of n, x, and c. Our n value is 4 and our x value is the number that we're gonna try to approximate, which is 1.1. And our c value, based on Taylor's formula, this is equal to x minus c. So 1.1 minus 0.1 is equals to 1. So our c value is 1. Replace n to 4 and x to 1.5, 1.1 I mean. And 4 plus 1 is equal to 5 evaluated at key over 5 factorial. X value is 1.1 and c value is 1. 1.1 minus 1 raised to the power of 4. So it said here that we should find the fifth derivative of our function, which is ln x. The first derivative is, so we're gonna apply the power rule here. Our first derivative is x 1x raised to the power of negative 1. Our second derivative is negative 1 times 1 equals to negative 1. Negative 1 minus 1 equals to negative 2. Our third derivative is negative 1 times negative 2 is positive 2. X negative 2 minus 1 equals to negative 3. Our fourth derivative is negative 3 times negative 2 equals to negative 6. X negative 3 minus 1 equals to negative 4. Sa fifth derivative is negative 4 times negative 6 equals to positive 4. Negative 4 minus 1 equals to negative 5. So our fourth derivative is equals to 24 over x raised to the power of 1. Taylor's theorem tells that k exists between x and c. So it will gonna be equal to 1.1 or 1 or 1.05. Which of these value will give us the maximum value for the derivative of f evaluated at k? So we're gonna go for 1 because as the denominator gonna go down, the whole fraction goes up. So if f is 1, our fifth derivative is 24 over x5. Our x value is 1 raised to the power of 5 is equals to 24. So our fifth derivative evaluated at k is 24. And 5 factorials equals to 5 times 4 times 3 times 2 times 1 is equals to 120. So 5 factorials equals to 120. 1.1 minus 1 equals to 0.1 raised to the power of 4. Instead of using this formula, you're going to take the absolute value of the error, which is less than or equal to the, calculate this. So we're going to have 2 times 10 raised to the power of negative 6. Or in decimal notation, it's going to be 0.00002. So our maximum error of the approximation is 0.00002.